Hi class, let's take a look at example 4. And in this example, the main event that they're describing here is to believe on the bad luck. So because in terms of the only possible outcomes are to believe or not to believe, this one is a binomial experiment. So in this case, your n, it's going to be the total number of subjects. So n is equal to 1236. The possibility of a success is 0.14, and for a binomial, q is equal to 1 minus p, or the complement. So in this case, 1 minus 0.14, we're looking at 0.86. Let me confirm that. 1 minus 0.14, 0.86. So those will be the values that we're going to be using for the evaluation of this problem, especially for Q. Now, on part A, they want us to evaluate the mu, the variance, and the standard deviation. So because it's a binomial, all of these formulas are going to apply. And as stated here, you're basically just looking at two main events, successes or failures. So for this problem, a success is to believe on the bad luck, and a failure is not to believe on the bad luck. So for the values of mu, as we evaluate this is going to be 1236 times the values of 0.14. So 1236 times 0.14, I'm getting that this is equal to 173.04. And let me just write it as mu is equal to 173.04. If it had asked for the expected value, we will round. So let me just write out the expected value. So expected value is mu is equal to 173. And then in this case, we're talking about adults. So the problem is not asking for the expected value, it's just asking for the values of the mean. The actual variance, it's going to be n times p and q. So for this one, it's going to be the 1236, 0.14, and then 0.86. So this is equal to and I'm getting 148.8144. Okay, so let's take a look at the standard deviation. And the standard deviation is going to be the square root of the previous answer. So technically 148.8144. And this is approximately, I'm getting 12.1989. And I'm just going to round to 3 decimal places, since they're asking for usual values. So 12.199. Okay, for the usual values, well, since some of these binomial problems in terms of the distribution may be bell-shaped, we're still looking at technically, well, plus or minus 2 standard deviations away from the mean. So for any usual values, and this is specifically if it's asking for like the software, you want to use the actual values, not the expected value that was rounded, but we're using in this case for the mean 173.04 minus 2 times the 12.199. And then comma 173.04 plus 2 times the 12.199. This is just for rounding for the software. So let me evaluate that. Okay, so let me tell you what I'm getting. So lower bound, I'm getting 148.642, and then upper bound 197.438, which in this case, for usual values, is going to be the interval that contains, I'm just going to round to the nearest integer. So in this case, 149 and 197. So we're talking about 149 to 197. And once again, we're talking about adults. That's actually it for the first part where we're doing basic evaluations. Let's take a look at evaluating probabilities. Now, as you evaluate probabilities, there's two main commands that we're going to be using. If it's asking for a specific value, that would be the PDF. And if it's asking for less than or equal, you're going to be using the CDF, or if it's also asking for less than. So it's a little bit confusing in terms of what we're using here. For example, on the first problem, they want us to find the probability that a total of 202 subjects believe on the bad luck. So we have to declare the variable like we did before, but in this case, it's subjects who believe in the bad luck. And because it's a total, so we're going to be evaluating x is equal to a 203. And let me run it on the calculator. Give me just a second. Okay, so let me show you the commands. So you're going to go to second and distribution. And because this one is an equals, you're going to be using the actual Binomial Pdf. So in this case, Binomial Pdf is at the bottom. It's here. And yours may be a little bit different. This particular one uses the values of n. So in this case, the 1236. And then in this version, this model, you can either put a comma, then the probability of a success. So for this problem is 0.14. And then how many? So we would be using the 203 for this one. So please run it, and I'm getting about 0.0017. Let me write it up. And I have the actual output already on the file. So this one gave us approximately 0.0017. Okay, let's take a look at the second one. And in this one says to use the same information. So we already declared the variable. We don't need to declare it again. But they're asking for less than 203. So in terms of a probability statement, this one says less than 203. Now, your random variable here is integers. So if it says less than, you're not going to include the upper bound. So in this case, less than 203 actually represents the probability of x is less than or equal to 202. And this is important because your answers are not going to run with the software. It's going to be a little bit off. So here we're talking about actual subjects. So less than 203, it doesn't say or equal. So that means that you have to round it to the next integer down that includes or equal. And once you round down, you're going to be using the proper command, which is going to be the CDF. So for this one, let me pull out the calculator. So once again, you're going to do the binomial, but this one is going to be the CDF. And then the 1236, comma 0.14, and then the 202. And that's going to be adding all the probabilities from x is equal to 0 all the way to 202. And I seem to have an error somewhere. Oh, I need a parentheses. Oh, I need the point. Okay, hold on. So Give me just a second. Okay, so 1236, comma, 0.14, comma, 202. There we go. Okay, so I already cut and pasted that portion there, but this is once again the important part. It's a CDF, and it's going to be evaluating all the way to 202 from 0. Technically from x is equal to 0. So CDF adds it, PDF is only one evaluation. So in this case, we're going to be ending up with the value of 0.99. I'll just leave it as 0.9911. That's what the software would have asked if it was like an assignment that is wanted you to just type in the final answer. That's actually it for this problem. It was just a couple of questions, but it's asking for less than statements, and less than within the binomial means you're not including the upper bound. So not exactly what we did on the other problems where we just said less than and then we included the equal.